Okay, so today we are looking at example 1, and we are on page 498, lesson 8-3. So, if we look at example 1, it says, Finn and Jonah attend different middle schools. They compare the number of hours students at each school spend on homework each week. Finn and Jonah each conduct a random sample of 20 students who attend their schools, and then list the data in order from least to greatest. What can Finn notice about the time spent on homework? So, if we look down here at our data sets, we can see, let me move this down a little bit. We can see that, first of all, the medians of these data points are different. Finn's median, I'm going to write it here, and I'm going to write it for Finn. His median data point is at 5, while Jonah's median data point, so I'm going to put a J, is at 7. So right off the bat, we can infer, so remember, an inference is that educated guess, we can infer that people in Jonah's class spend more time doing their homework each week. We also can look at our minimums and our maximums, and we can say those are the exact same. And then we can look at our difference between our IQRs, and we're at around 3.5 here, and around, I'm going to say 6.5 here. Then at this one, we are at 5.5 and 8. So, based off of this data, we can infer that Jonah's class spends more time on homework. I hope you can see that. Okay, so now I want you guys to do your try-its here. Okay, it says, Kona gathers the heights of a random sample of 6th graders and 7th graders and displays the data in box plots. What can you say about the two data sets? Okay, so first of all, the median, we know to find median, we are looking for this line. So my median for 6th grade students is about 62, and for 7th grade it's about 63. So the median of the blank grade sample is greater. So the 7th grade sample is greater than the median of the 6th grade sample. Also, remember, when we are talking about variability, we're talking about the size of our box. So I'm going to write a note, and I want you guys to do this too. Larger box equals larger variability. And by box, I mean between Q1 and Q3. So our quartile 1 and our quartile 3. We can see just visibly that the 7th grade has a much larger variability because the box is larger in between our quartile 1 and our quartile 3. So the 7th grade sample has greater variability. Now let's look at example 2. It says Finn and Jonah analyzed the measures of center and variability from the data they collected. Do these measures support Finn's assessment of the two data sets in example 1? So if we're looking, remember we talked about how this is quartile 1 and quartile 3. So this area from here to here is our quartile 1 data. Here is quartile 2, there's quartile 3, and last but not least, there's quartile 4. So we said that each quartile, I'm going to write it here, each quartile is 25% of my data. Now, if we look, based off of this data it gives us, the first quartile is at 3.5. We agree with that. And Jonah's is at 5.5. We agree. The median, so we're looking here, is at 5, and the median is at 7. Your third quartile is at 6.5 and 8. Perfect. And last but not least, our interquartile range. So interquartile range is quartile 3 minus quartile 1. So we would take quartile 3, so 6.5 minus 3.5, and we would get 3. Then we would take 8 minus 5.5 and get 2.5. So based off of this, we can compare our median, and we can see that our median is larger in Jonah's, which is what we said over here in example 1. And then we can also look at our interquartile range, and our IQR is larger in Finn's. And, oh, I spelled Finn's name wrong, whoops. And the larger, I want you to write it down here, the larger the IQR, the larger the variability. Why this is the way it is let's look back at example 2. If I take my interquartile range, so 68 minus 58, sorry, that's crooked. If I take 68 minus 58 here, I would get my interquartile range as 10, versus if I do 64 minus 58, I would get an interquartile range of 6. So I already know that this is a larger interquartile range because my box is larger, which also means there is more variability. And last but not least, let's look at example 3. I think last but not least. Yep. Example 3 says, Mr. Bunsen had students grow the same type of plants in 2 different rooms to set the growing conditions. The box plot shows the heights of all the plants after 3 weeks. How do 2 populations compare, and what inferences can be drawn? So, if we look at room 7D, we can see that our median is 12, and in room 7G, our median is also 12. If we look at our minimum for room 7D, we're at 5, and our minimum here is at 18. If we look at our IQR 1, we are at 8. Our IQR 2 is at 14. And last but not least, our interquartile range, 14 minus 8, which gives us an IQR of 6. So that is all for room D7 or 7D. Now if we look at 7G, we already said our median was 12. Our minimum is 6. Our maximum is 20. Our interquartile or our quartile 1 is 10, and quartile 3 is 16. And then our interquartile range is 16 minus 10, which gives us 6. So we can see that our median heights of the plants are the same. Our IQRs are the same. But if we compare the height difference, this minimum is at 6 and the maximum is 20. This minimum is 5 and the maximum is 18. So based off of this data, we can infer that room 7G, oops, that doesn't really look like G there, 7G grows larger plants. Because their IQR is the same, the median is the same, but the maximum and the minimum is what we're comparing in this one. And my maximum and my minimum of 7G are larger than my maximum and minimum of 7D.